Hello students, it's Professor Capko again, and it's time to talk about something that everybody hates, fractions. Those friggin' fractions. Gotta be honest with you, I don't particularly like them either. That's why we've got a few tricks that we can learn to deal with them. We can get them out of your life, at least partially, while you're solving some algebra problems. So let's take a look at some ways to deal with those friggin' fractions. Let's say you have a problem that looks like that. 1/3 x is equal to 5. Well, the 1/3 is the coefficient, the x is the variable, and the 5 is the constant. The coefficient and the variable are multiplied by each other. We know that because they're right next to each other. That means that this 1/3 is multiplied by x. We don't know what the x is right now. That's what we're going to find out. So if there were a plus or a minus between them, then we'd know that they're not being multiplied. But in this case, they're being multiplied. So we want to solve for x, and that means we need to get the x by itself. The fancier way of saying that is to isolate the x. So I'm going to circle this x, as I recommend. That way, you know what you're solving for. Again, and this one is pretty easy because there's only one variable, there's only one thing to solve for. But if you start getting more complex problems and you have to solve for a particular variable and there's more than one, I don't want you to forget while you're stressed out which one you're solving for. So let's build the habit early now while you're solving them. So we have 1/3 times x is equal to 5. I'm going to show you my trick now to get rid of that friggin' fraction. Here's all you need to do. Listen closely. Take a look at the fraction. You have a numerator of 1 and a denominator of 3. The numerator is what's up here, and the denominator is in the basement. So look at what's in the basement here, and what I want to do is multiply the whole problem by what's in the basement. Whatever that number is, I want to multiply the whole problem by it. So I'm going to take and write the 3 out here. And I'm going to put parentheses next to it because that tells me it's multiplying. 3 times, and I've got 1/3 x. I'm rewriting this part of the problem. Bringing it down, right? This whole problem. Bring down the equal sign. And I've got a 5 over here, but I need to multiply both sides. If you remember in some of my other videos, I talk about the pony rule. The pony rule tells you whatever you do to one side, you've got to do to the other. Just like if you give a pony to one child, you got to give a pony to its brother or sister if you want to stay in balance. So we're going to follow the pony rule here, and we're going to multiply the 5 times a 3 as well. So we've got all this stuff being multiplied. So I've got a 3 on this side and a 3 on that side through multiplication. Just like if I had a scale and I put it was in balance and I added 3 pounds to one side, if I add 3 pounds to the other side, it'll still be in balance. Okay, so now it's time to multiply. Well, 3 times 1/3. Well, 3 1/3 is a 1, so the 3 and the 3 cancel out. And if you think about that, 1/3 times 1/3 times 1/3 is 1. It works out that way. So so that cancels out, so I'm left with a 1x on this side. On this, and bring down the equal sign, on this side 5 times 3 is 15. We don't usually write this 1 here. That's usually invisible. So if you write it there, that's fine, but you'll be looked at like you're using training wheels. So we're going to rewrite this as x equals 15. And that looks like a solution, folks. It looks like a solution. But as I told you, I always want to rewrite the problem and check it. So 3x is equal to 5. 1/3 x equals to 5. So I'm going to rewrite it with a box. So I got 1/3, and I've got an x box here, equals 5. And what do I plug into the x box? What we found, 15. We put that in there. So we've got 1/3 times 15. Well, we multiply straight across, so that is like 15/3 is equal to 5. 3 goes into 15 5 times, so it's 5 is equal to 5. So we know that it works. Our answer is x equals 15. So that's the first problem, dealing with that friggin' fraction. Okay? So always make sure you check your answers after you work with it. Let's do another one. kicking it up a notch here. Let's see, you've got 3/4 minus x is equal to minus 3/4. All right? So we can do the same thing. I want to do the same thing. I want to solve for x. So I'm going to circle that so I know that's what I'm solving for. And I want to get rid of these friggin' fractions. In this case, I look at what's in the denominator, and I've got a 4. I got a 4 in the basement there. So now I'm going to multiply both sides of the equation by 4. So I've got 3/4 minus x. I brought this whole side of the equation down and put it in parentheses, and I'm multiplying the whole thing times 4. I bring down my equal sign, and then on this side I've got negative 3/4. I'm going to multiply this whole side by 4 to keep it in balance following my pony rule. So now we have to distribute because I got 3/4 minus x. So I'm going to multiply 4 times 3/4. Well, that 4 and that 4 cancel out, because if I had 3/4 and I multiplied it by 4/1, which is essentially what 4 is, and I multiply straight across, 3 times 4 is 12. 1 times 4 is 4. 12 divided by 4 is 3. So we can take a shortcut there and say these 4's cancel out. I've got a 3. And then I've got a 4 times minus x. So that's minus 4x. I have to distribute. Multiply by the first one and the second one. We have to distribute because there's a minus sign between there. If there's a minus sign or a plus sign, we know we have to distribute. Bring down the equal sign. All I do is bring that down. And then I've got 4 times 3/4. Again, these 4's cancel out. So I've got minus 3 here. Now, I still want to solve for x, so I've got to get the x all by itself. So I'm going to subtract 3 from this side because it's a loose number. Get it out of there and subtract 3 from this side. Draw my line. 3 minus 3 is 0. I bring down my minus 4x. Bring down my equal sign. And minus 3, and I take away 3 more. I'm already negative 3, and take away 3 more is negative 6. So I can then, now this is negative 4 times x. I want to divide both sides by negative 4 because I want to get that x by itself, and I want to do the opposite. So negative 4 divided by negative 4 is a positive 1 because negative divided by negative is a positive, so I get positive x. And I've got negative 6 and negative 4, so a negative divided by a negative is a positive, so I got 6/4. Well, that looks like something that I can reduce. First of all, it's an improper fraction because the numerator is larger than the denominator. So we can do that by putting both numbers into a factor tree. I take my 6 and I start with the smallest factor. That is I want to do only prime numbers. And we can do a video on prime numbers later, but the smallest prime number is 2. So 2 times 3 is 6, and my 4, smallest prime number is 2. 2 times 2. So my 6 actually becomes 2 times 3, and my 4 becomes 2 times 2. Well, 2 over 2 is 1, so my x is equal to 3/2. So that looks like a solution. If you need to put it into a mixed number where there's a whole number and a fraction, then we just do some old school division. I take my 3, divide it by 2. 2 goes into 3 one time. 1 times 2 is 2. Minus 3 minus 2 is 1. So here's my big number, 1. And then here's my remainder, 1. And here's the bottom of that, 2. 1/2. So there's my answer for that one. And we could go back and plug it back in, but I don't want to take time to do that. You're going to do that with each and every problem to make sure that it's correct. Let's do another one. Let's say we have a problem that looks like this. 1/2 x plus 2/3 is equal to 5. Well, in this case, we could still multiply by the 2, but I'd rather get rid of both fractions. I want to get rid of both of them. So we're solving for x, and I want to think of a number that both 2 and 3 go into evenly. I'd like to find the smallest one if possible. It doesn't have to be, but it sure would be nice. Well, 3 doesn't go into 2. 3 is fine, but 2 doesn't go into 3 evenly. 4, 2 goes into 4 evenly, but 3 doesn't. 5, neither one goes into evenly. How about 6? Well, 2 goes into 6 evenly. Yes, 2 times 3 is 6. And 3 goes into 2 evenly. So let's use 6. And by the way, an easy way to find a number like that is just to multiply them by each other. 2 times 3 is 6, so that tells you we're going to multiply both sides by 6. So I get 6 times 1/2 x. I'm just rewriting this part of the problem, plus 2/3, close parentheses, equals parentheses 5, and following the pony rule, I'm going to multiply this side by 6 as well. So now, since I've got 1/2 x plus 2/3, I can't combine, and this one doesn't have an x, this one does. I'm going to have to distribute. So 6 times 1/2. Well, 2 goes into 6 3 times, so this is 3x. And then I'm going to take my 6 and multiply it by 2/3. Well, 3 goes into 6 2 times, so I've got 2 times 2 is what I wind up with there, because it's 2 times whatever the 6 divided by 3 is 2, so 2 times 2 is 4. Bring this over, 5 times 6 is 30. So I've got 3x plus 2 times 2 is 4 is equal to 30. So far, so good. Now I want to get the x by itself because I'm trying to solve for that, so I want to get this loose number out of here first, this 4. So I'm going to subtract 4 from both sides following my pony rule. So I bring down the 3x, I didn't do anything to that. 4 minus 4 is 0. Bring down the equal sign, 30 minus 4 is 26. Now, the relationship between the 3 and the x is multiplication, so I want to do the opposite, which is division. So I'm going to divide this side by 3 and divide this side by 3. 3 over 3 is 1, so I've got x is equal to 26 thirds. Kind of an ugly number there. X is equal to 26 thirds. We can see if we can reduce that to an improper, it is an improper fraction, I'm going to reduce it to a mixed number. So I got 26, do some old school division by 3. Okay, so how many times does 3 go into 26? Right, 8. 3 times 8 is 24. Subtract, that brings down 2. So 8 is my whole number, 2 is the numerator of my remainder there, and 3 is the denominator. 8 2/3. So that is how you find and deal with those friggin' fractions. I hope you found that helpful, and if you have more questions, put them in the comments. Make sure you like this video if you like it, and subscribe to my channel. Any type of problems you want done, put it in the comments, and I'll try and get to you and make a video for you. If you enjoyed this, let me know. All right, I hope all is well in your math, with all your math that you're learning. And this is Professor Capko. I'll see you next time.